Okay, so here we go. We're going to be talking about file input and output in MATLAB today. Okay, so we're going to be using the fprintf function that we've been speaking about in class a number of times, and we'll be talking about saving and loading files. So MATLAB is great for doing all sorts of analysis and graphs and calculations on data, but it's a question as to how do you get that data into MATLAB. So sometimes, and most of the time this is what you've been doing, you type the stuff in and it goes into your MATLAB program, and then typically you're outputting whatever calculation result you've got to the screen. But it's also possible to load data from a text file or an Excel spreadsheet or something like that, do the analysis on it, and then output the result either to the screen or to a file on a network drive or on a USB stick or something like that. And we've been using XLS read, or we've been showing how to use XLS read and XLS write, as well as CSV read and write. Whoops. And CSV write. So that's for specially formatted text files. And we've also looked at DLM read. And you can also use the import wizard. So the import wizard can be used to read data files as well. So there are lots of ways that you can get files to be read into MATLAB or to write to them as well. Now fprintf is this great function for file printing. Okay, so you can print data or write data to a file. Okay, so think of the F as the F in file. And it can output data or the result into a file using 3 steps. The first step is to file open, or fopen. After that, you print data to the file, and once you're done printing data to a file, you have to file close. So fclose. Now, how do you do file open? So file open. The file open command, or fopen command, creates a new text file or opens an existing text file in the current directory. So whatever directory you've got MATLAB pointing to, that is the current directory. And if you type pwd in the command line, MATLAB will report the actual directory that it finds itself in. So it's an easy way to figure out where you are, or which directory you find yourself in. Now, the way that you use fopen, or file open, is to tell it the file name, so the name of the file that you want to open, as well as the type of permission that you want to grant it to fopen when opening up this file. And you need to assign a file ID as the output variable to this command right here. So you have file ID as the variable called the file identifier. It can be any variable name. So just like any other variable that you would have in MATLAB, you could call it this. File name with its extension. So is it a .txt file, or a .doc file, or a .xls file? All of these file names have extensions. They're typically 3 or 4 letters after the period, and you have to include that as well. And then finally, in terms of permission, you can either have read permission, write permission, or a pending permission. And that's sort of like concatenation that we were speaking about in class earlier. So when you append, you're putting the data at the end of the existing file. And all of those quotes should be that straight up and down quote, not the smart quotes. Okay. Now, here's some examples for file open. So here, we're assigning the result of file open to FID1. We say that we want to open file 1.txt, and we want to have read only. Now, after that, you can open up a different file, say file number 2.txt, and you permit it to also write to it. And then finally, we can have a different file ID, and let's say we wanted this to be file ID 3 is equal to file open file3.txt, and this means that we want to append information to the end. So you have to be careful about this, because basically if you aren't careful, you might overwrite existing data. If you use the appending argument right here, then you can ensure that whatever data was in your file originally doesn't get written over, and any new data gets appended or added to the end. Next, once you've opened that file, you actually have to write information to it, and that's where printf comes from, or fprintf. So once the file is open with either a write or an append permission, fprintf can be used to write output to the file. So fprintf is used in the same way as it is used to display output in the command window, except instead of sending data to the command window, you're sending it into the file. And you do this basically line by line or character by character. And so here's an example right here. So we've got our standard couple of variables. A is equal to 2, B is equal to 5, C is equal to 4. We come up with some average value for this, so this is a very standard calculation. We say file ID, FID, is equal to fopen file1.txt. So here you're going to effectively create a new file if it doesn't exist already, and you're going to give it write permissions with the W right here. And then you say, once it's open, fprintf to file ID, which is file1. Okay, and it says the average value is 5.2f, so a floating point with a buffer of 5 and 2 values to the right of the decimal point. And then you've got a new line right here, and it sends in the average value. So it will actually write this entire line. The average value is with a number, and it will write, well, here's the answer right here. The average is 3.67, and this will be an actual line in file1.txt. All right, now once you've opened, then written to the file, you need to close the file. And this is similar to what happens when you stick a USB stick into a computer and you're supposed to eject the USB stick afterwards. It's like closing the USB stick. So in this case, you're closing the file. And that's a safe way of stopping any writing that's going on to the file. So when writing data to the file, when it's complete, the file should be closed using fclose. And you do it like this. You say fclose, and then in parentheses, FID. So this is the file ID from the fopen call from before. And here's an example. So here we do the same average calculation. We open the file, then we write to the file, and then finally we close the file. So 1, 2, 3. And you can write to the file as many times as you want. And so these are the 3 steps that we have to take into consideration. So open it, write a bunch of times, and then close it again. So here's an example right here. Write a MATLAB program that converts the distance from miles to kilometers for a miles value in the following table. Print out the table in a file called conversion.txt. So we have miles, we have kilometers, and we have values that get converted over. Okay. So here's the solution to this particular problem. We go and we do a clear, and then we create a vector to store the miles values. That's pretty standard. Then we compute the corresponding kilometer values, so kilometer is equal to a conversion factor of miles. Write the data into a conversion.txt file. So we have to assign a file ID once we've opened the file. We're going to call it conversion.txt, and we're going to allow writing to it. Now, if the file doesn't already exist, it will be created in this particular case. So we can also assume that there will be the creation of a file if it doesn't already exist. File printf, so we're going to write to the file, and we've got a file ID. We have miles and kilometers, and this will be the row, the header row in the text. And then we have a for loop. Look at that right there, a for loop, and it will write 10 times fprintf, and you're going to see a decimal value there, a floating point number there, miles and kilometers, and it will do it 10 times. Once it's done, so this will be 10 times right there, and once it's done, it will close the file. And there, I suggest actually that you open it up in a text editor and see, did it actually make what we thought it was going to make? Here's a second solution to that problem. So again, we do the clearing, we come up with our vector for the miles, we come up with the corresponding vector for the kilometers, and from there, we create a table that has 2 columns, miles and kilometers, and we go file ID is equal to file open, so we're going to open or create the file. Then we're going to create the header at the top of the file, and then in one shot we will write the table, or sometimes we like to call it a matrix of data, and it will write it out. And there you close the file. Bob's your uncle, you're done. Okay, here's another exercise right here. Write a MATLAB script file that asks the user to input 5 students' names and GPAs, outputs the students' names and GPAs into a text file called students.txt, 1 student per line, and here is what you would want it to look like. Okay, so we have names and GPAs, and obviously Amanda's got the highest GPA right there. She's pretty awesome. Okay, so we go solution to exercise number 3. We do some clearing just as we normally would. We open the file or create the file, and it's called students.txt, and we're going to give it writing permission so we can write to that file. We're now going to prompt the user in a for loop. We're going to ask for the name and the GPA, so GPA and name, and then once we've got that, then we're going to print to the file. So we're going to write to the file both the name and the GPA for the value that was just entered. And once we're done with that for loop, which is going to happen 5 times, we are going to close the file, effectively saving it. Okay, so now that we've spoken about how to use fprintf to write individual lines to a text file, the next thing we're going to do is talk about saving and loading. And these are different than the fopen, fclose, and fprintf commands that we were just doing. They have a different application. So the save and load commands are ways of saying that you want to save or load the history that you had in MATLAB. So let's say you were doing some work and you were slogging at doing your data analysis for some experiment, and it took you 3 hours to do it, and you know that you have to walk away from the lab computer because somebody else has to use it, but you don't want to lose all that stuff that you just did, and you didn't write a script to make all that happen. You've been doing everything from the command line. Well, you can save all of the variables, all the work that you just did up to that point, and save it so that you can recover it another time. You can save the stuff that was in your workspace and load it up later. So the save and load commands, so save and load commands, are used for saving and retrieving data to and from a disk file. Now that's pretty clear, but in MATLAB the distinction here is that it's saving and loading data with respect to your workspace. So save command can be used for saving the variables that are currently in the workspace, and the load command is used to retrieve variables that have been previously saved back to the workspace. So it's all about the workspace. What is the current state of MATLAB with respect to your variables, and can you get them back? So the save command is used for saving all or some of the variables in the workspace. To save all the variables in the workspace, you just say save and the file name. And this will save everything. So everything that's currently inside of your workspace, that little sub window that you've got that talks about all the variables and their values, that'll all get saved. And you can also do it like this: save with the file name and the single straight quotes in parentheses. Either way, totally works. With either command, all the variables currently in the workspace are saved to a file called, and here this is the important thing, file name dot mat. So here you don't actually have to say what the file extension is, unlike f close and f open, or sorry, with f open. Here you just say what the top part of the file name is, and it will add the .mat. And this is important because .mat is a binary file, not a text file. So you can try and open it in Notepad or Word. It'll look like garbage. And that's because MATLAB is saving it in a proprietary format that only it really is capable of opening. So here's an example. We stored a vector called v. We got a matrix called A. We've got a scalar called B, and these are all saved in the workspace. So if you take a look in MATLAB, there's this little window that's the workspace, and you'll see that V is going to be listed there, and A and B will be like a 1 by 1, and A will be some matrix that seems to be about 6 across and 2 rows in height, and then so that'll be what, 6 by 2, and then V will be a 1 row by 4, and that'll be in your workspace, and all of that will get saved into data1.mat. So data1.mat is a binary file. It's really not readable by other software, but it can be read by MATLAB via the load command, or in fact you can actually go and load it from the file menu in MATLAB. Okay, so you can save it and you can load it. So the load command is used for retrieving variables that were saved with the save command back into the workspace, and they were saved to a file that had a .mat or .matlab file extension. So importing data that was created with other applications and saved in the ASCII format. So you can also do that. So that's optional, and load has some smarts to it to help you with that. To retrieve all of the variables from a .mat file, so remember, with the save command, it saves all of the variables that were in the workspace. You can, by default, load all of the variables as well. And you just go load file name or load parentheses, single quotes, file name, and it'll load it up. Give it a shot. See what happens. And notice that you don't have to add .mat. All right? All the variables will get loaded up. That's fabulous. Now, if you didn't want to save all of the variables in your workspace, you can do it this way. You can save the file name without the .mat, and you can say, I just want variables 1 and variables 2, or so var1 and var2, those two variables, and it will only save the contents of those two variables. Alternatively, you could say save, open parentheses, close parentheses, file name, comma, var, comma, var1, comma, and then var2, comma, all with these single quotes around them. So this will allow you to be selective about what variables you save and what variables you're going to load later, which is good. Okay? So here we go. So we create a variable called v, we create one called a, we create another one called b, and we don't care about b, so we say save data2, so this is going to be your file, and I just want to save the variables v and a, so a vector and a matrix, and basically that's all that's going to be inside of it. And if you try and load all of the variables, only v and a will show up. There will be no b. And just to make sure when you're practicing that this is actually the case, make sure that you type in clear or clear all ahead of time, and it will clear all of the variables ahead and then load them up. Or if you really want to test it, shut down MATLAB after you've saved the data and load it up again with a clear workspace and try it out, and you'll see it works. It does. I promise you. Okay, so so basically you can save with individual variables, but let's say you've got a data file that has a whole whack of variables. You've got var1, var2, var3, var4, var5, etc. But you're only interested in var1 and var2, so these two variables. This is how you do it. You go load, file name, and only the variables that you're interested in. And because this is a binary file that is proprietary to MATLAB, MATLAB knows how to find those variables and it'll load up for you. It's really convenient. Here's the alternative way of writing it as well. And you can see that if you just type in clear and you've got a file already that exists that says data1, just load data1 and you want one particular variable, A or var1, var2, it will load it up. And only that variable. So it's a nice way to get a clean workspace after a week's worth of data gathering and analysis and that, and you've come to the next week, and all you want to do is take a look at that one variable that's interesting from that experiment that you did. This is how you do it. Really easy, straightforward. Okay, so taking a look at the save again, the save command can be used for saving in ASCII format. Okay, and we spoke about ASCII in class. ASCII refers to the plain text, letters, numbers, symbols, etc. No binary business at all. No strange, weird computer command. A text file that can be loaded by programs like MATLAB or Notepad or Word or whatever text editor you want to use. So if you want to make sure that the data that you're saving in MATLAB is available, for instance, let's say you did all your work in MATLAB on some psychology experiment that you were doing, and your supervisor or the client doesn't have MATLAB, you need to be able to give the data to your client or to your supervisor, and you know they don't have MATLAB or anything tricky like that, then you can just say, save it as an ASCII file, and there's your file name as well. So save to an ASCII format, and it will output the information properly formatted for either MATLAB to open it up later or WordPad, Notepad, etc. And you can also specify specific variables to save as well. And MATLAB will do a fabulous job of saving it just right, so only those variables are saved, and it's done in a very compatible ASCII setting. Okay, so here's another example right here. So we got a vector, we got another vector, we got a scalar, so v, a, and b. We save as an ASCII or text file. That's what that means. Data3.txt, and we're just going to say that it's, we're going to be explicit about the file extension right there. So we know it's not a binary.mat file. And we say that we only want to save v and a. And then if you take that file and open it in Notepad or Word or WordPad or something like that and try it out, you'll see. Then the contents of the file will read something like this. And you'll actually see the raw data, but in ASCII format, so text format, it will be written out like this. It's awesome. Okay, so you can also take a look at the file by typing in the command window, type, and the name of the file. And this will actually sort of engage sort of a fake typewriter mode that will type to the screen each of the individual lines from that text file right there. Okay, now the load command can be used to import data in ASCII format as well. Okay, so we can save in ASCII format and we can load it as well. So you have to be careful. However, the content of the file should be one of the following: only one value, a scalar, a row vector, a column vector, or a matrix with the same number of values in each row. You got to be careful. Okay, so you have to make sure that you've got, for instance, and this is typically the most common way that I think a lot of people would be saving data. You have a bunch of rows of data, and each row has exactly the same number of columns in it. Okay, and that would be typical. So you have a format here. You go load file name, and it outputs to a particular variable, and it can be any variable you want to call it. And this will read in the data to the of the file. It will read in the data from whatever the file called file name is, and assign it to a variable called var name. And then you can manipulate this variable right here any way you want. That would be typical of MATLAB. Okay, so here's an example right here. A is equal to, and this is a matrix. Okay, and it has the same number of columns for each row. So save in ASCII format in text mode to a file called data4.txt, and you're going to save the matrix or the data A. Later on, type in clear all, and then load that data. Say load data4.txt and assign the file information to variable B. Okay, so let's have some fun with some files now. Now, the first exercise right here involves a file called iris.txt. Okay, and iris.txt is found on Moodle, and you can download it from Moodle. The information itself is related to a set of data that was developed earlier in the 30s about different about irises, a type of flower, and so this data set about flowers talks about an iris, and this is an iris right here, and it talks about the difference in characteristics between the petal and the sepal. And the sepal is this little sort of green leaf that you would find between individual petals. Okay, and what it does is it talks about in the data set, and this is what the data looks like right here. The first row describes, each row describes a particular type of iris, and the first column is the sepal length, so that's that little leaf right there, as well as the next column is going to be the width of the sepal, and then the third column is going to be the petal length and the petal width in the fourth column. Okay, and then the last column that we have indicates the category of the flower itself, okay, of the iris. So here's an example of how to take a look at that data and to get some mean values out of the iris information file. Okay, so what we do is we do our typical clearing, and we load the data file, and you just have to download it from Moodle. So load the data file, which is a plain text file. You can actually view it in Excel or WordPad or something like that, and assign all of the information from it into a variable called iris. Now it's going to have a bunch of rows, and then each row has the same number of columns, which makes it easy for MATLAB to read. Then you're going to run through a for loop, and the for loop is going to run 4 times. Why? Because of the number of columns that we want to go through. Okay, and so we're interested in taking a look at the physical properties of the iris. So there's only 4 of them, 2 widths and 2 lengths. And we're going to look at the mean values for all of the rows. So all rows and each individual columns numbered 1 through 4 via the index k. And we're going to assign those values to a new vector called A, and A has 4 columns in it as well. And then it will display the average values of A, so the average lengths and widths of the petals and the sepals of the iris. So here's another way of doing it. We do the typical clearing, then we load our iris.txt file, we assign it to iris, the variable, then we say m is equal to mean of the iris file, variable, sorry, not the file itself, but the variable that all the data was stored to, and then we display only columns 1 through 4. So the 2 widths and the 2 lengths of the sepals and the petals. Okay, so we're on our way to the third exercise, but what we need to do first is talk about something called z-score. Okay, and z-score is a function that we're going to be writing. It takes a vector as an input, and it normalizes the vector, that is the information that was input into it, by computing what's referred to as the z-score for each element of the vector. And basically what it is this score is equal to each element of the vector minus mu, which is the, in this case, this is going to be the mean value, and sigma which is the standard deviation. All right, and so you do this, you get a z-score for each individual e, or each individual value in the vector. And we're going to be using this in some of our functions that come up next. Okay, so if we want to do this z-score business, we need a function that outputs the value y for a function called z-score, and then x is the input. And the way to do it is basically you take your x variable, you calculate its mean, you calculate its standard deviation, and then you calculate the output, which is equal to the individual values of the vector x minus the average value, all divided by the standard deviation. And it will come up with a number for each element of that input vector that represents that score. That's effectively a relationship between the value itself, the average value of the data, and the standard deviations. Okay, so another way of writing z-score is effectively the same thing, and here we just say the output is equal to individual values of the vector minus the mean value, all divided by the standard deviation. Okay, so we're going to use that result in exercise number 3. So again on Moodle, there's a file called file1.txt. Okay, so the course website, we're talking about Moodle here. And you want to write a script that reads the value or reads the data from file 1. And each file 1 contains a list of values, one per line, into a vector. You're going to load that into a vector using the load command. And you're going to calculate the z-scores, that's the function from exercise 2, into the vector using the z-score function, and output the z-score into a text file called z-score1.txt, and you're going to do that using the save command. Okay, so here's a solution for that particular problem. You want to read in the data, so you load or read the data, and you would have had to download file1.txt first and place it in the directory that MATLAB thinks it should be in. And if you don't know what directory you're in, remember, pwd. Type that into the command window without the period. Type in pwd into the command window, and it'll tell you what file directory or folder your MATLAB is currently pointing to. So you want to load it, and then you want to have the calculation of the z-score, which means you actually have to create a file that contains that function, and also save it in the same directory as file1.txt. So that all has to be in the same directory. Then once you've done the calculation of the z-score, you're going to write the z-scores into a file named z-score1. So save in ASCII format z-score1.txt, and you're just going to save the value z that had been saved into or had been put into a variable earlier. Okay, next, exercise number 4. Very close to exercise number 3, but this time we're going to use fprintf. And we're going to output values that should only be printed with 3 digits after the decimal point, and we're going to use fprintf because it gives us control. Okay, control is good. So again, you do your clearing, you do your loading, you assign into a variable called v, you take that v, you run it through the z-score function. Remember, file 1 and z-score need to be in the same file folder, and use that handy little pwd to make sure that you know where you are. Then, once that's all been calculated, then you want to create a new file called z-score2.txt. You want to give it write permission. You want to open it and assign it a file ID. All these steps are important. From there, you want to use, in the next step, you want to use file printf or fprintf. You want to use that file ID, which has been defined right here. And you want to say that it is a floating point number with 3 points after the decimal point, and a new line, and you're going to be assigning values from z, which has been calculated right here, into each of those lines. Once that's all done, you close the file. You want to make sure that you're closing the right file. File ID is what was assigned over here, and you're done. Okay, here's the next exercise. Exercise number 5. Download the file iris.txt again. All right, so that was from Moodle. Each row describes an iris flower. We talked about the sepal length. We got the sepal width, the petal length, and the petal width. And you want to read that file. You want to normalize each of the first 4 columns. Then you want to convert the values in each of the first 4 columns into their z-scores. You want to keep the last column intact because that's the type of iris that you had, so you don't want to do any normalization on that. You want to save the converted matrix into a file called iris_z-scores.txt. And that underscore right there is typically found near the delete key on the upper right-hand corner of a US English keyboard. All right, so here's the solution to this. You want to load that data file that you downloaded from Moodle. You want to save it into a variable called iris. So that's a variable. From there, you're going to run a for loop that goes through 4 columns. It's going to go through the 4 columns, so every row, each column one at a time, of the iris variable. Going to run it through z-score. Okay, so effectively you're putting a vector. You're putting a vector of iris values. Who knew you could make a vector of a flower? So you take a vector of iris values, so 1 column at a time. You're going to run it through the z-score function. You're going to output that value into a new matrix called z. From there, you're going to concatenate z with the 5th column of the iris data set. And here you go. So you're going to have your normalized iris data set, which was z with a new column. Okay? And that's the 5th column from the iris data set, which contains the type of iris. And you're just going to add that to the 4-column z matrix that you had earlier, that you calculated earlier up here. Now you save all of that to a file called normalized iris. So you're going to save the matrix as an ASCII file, save the ASCII file as a file called iris_z-scores.txt, and you're going to take only your normalized underscore iris data, which you calculated right here, and you're going to save it like that. So you're selectively saving the data. Okay, so here we go. Here's another way of solving this particular problem. The clearing, the loading, that's all pretty normal. We've got a for loop right here that extracts all the information that we need from the iris data set that have been saved over here. Then we're going to concatenate z with the 5th column of iris into a new matrix. So here's your normalized iris. So this all should look familiar. Now let's use fprintf and file open and file close. So we do file open, assign everything, this file identification to FID. We are going to open or create, in this particular case, iris_z-scores.txt. We're going to allow writing to that file. And then we're going to fprintf to the file ID. So we have to identify where that file is or which file it is. 1, 2, 3, 4. 4 different columns per row. And then the type of iris. Then a new line right there. And here is your normalized iris data. All that gets done. It gets done, basically it updates all of the rows all at once as per this sort of column format right here. It gets all that done, and then you close the file. Here's a third solution to it. Basically do all the same thing that you would do at the top here normally. Then you do your normalized iris. Here we've got file ID, file open, iris, z-scores.txt, and you write to it. And here we have a for loop. Okay, for those of you who are comfortable with for loops, this might look a little bit more obvious. So for k is equal to 1 through the size of iris, comma 1, fprintf file ID. So now we know how many iterations we're going to go through on that for loop. File ID, and then we have 1 column of data, another column of data, another column of data, another column of data. So here we have our normalized values of the iris petal, sepal lengths and widths. Then we have the type of iris right there. We have a new line right there. And here is that variable that we were interested in that we calculated earlier. And once that's all done, we close our file. Okay, so exercise number 6. download the marks.txt file, and again, that's on Moodle. The first column of the mark is the student ID, and the second column is the student mark. Write a MATLAB file that reads the data in marks.txt into a matrix and then converts the numeric grades into letter grades according to here. And you're all hopefully hoping you're going to get A pluses up here. So you're going to root for the underdogs in this particular class. So write the student IDs and the letter grades into a text file called grades.txt, and you're going to basically say student ID 302, you got a B. Student ID 312, you get an A+. Okay, so here's the solution to exercise number 6. Clear, load the marks.txt file. You're going to take a look at what are the number of rows. So you're looking using the size command right there. You're going to open a file. There's your file ID. You're going to open that file and you're going to call it grades.txt, and you are going to give it write permission for k is equal to 1 through the number of rows, and then you've got an if, else if, else if, else if, else if, else if, else by default, and then end. All these, this structure right here gets completed, and then you close your file. Now notice that we're not using a switch case statement here, and the reason is because we have ranges of values. Under 40, between 40 and 50, but we can state this as under 50 because the under 40 has already been taken care of earlier in the if-else. So if there's nothing under 40, nothing under 50, then we take a look at anything under 60. So this is basically 50 through 60 right at this point right here. So this would be 50 through 60 because under 50 and under 40 had already been taken care of. Then we take a look at under 70, which means this is going to be between 60 and 70. Then under 80, so this is going to be 70 to 80. Then under 90, this is going to be 80 to 90. And then basically you're left with 90 to 100 for A pluses. So we've got a range of F all the way through A plus. Okay, and there you have it. That's how you'd solve that particular problem. Okay, I believe this is the last one right here. This is a calculation of wind chill. So the wind chill temperature, T_WC, is the air temperature felt on an exposed skin due to the wind. So last week we had a big storm here in Toronto, and it got really cold, apparently. And this is how you do the calculation of wind chill for that really cold day. So in US Fahrenheit units, okay, we calculate the temperature of wind chill as this calculation here, 35.74 plus 0.6215 times the temperature. Okay, then 35.75 times velocity to an exponent of 0.16, and then you've got your 0.4275 multiplied by the temperature multiplied by the velocity to an exponent of 0.16. You don't have to memorize this for the exam. It won't be on the exam like this, okay? So where T is the temperature in Fahrenheit, V is the wind speed in miles per hour, and you want to write that MATLAB program that does the conversion from temperature and speed into the wind chill values. Okay, so here's your solution. You've got your clearing, and then from there you have a list of Fahrenheit temperatures. You open a file called the windchilltable.txt, and you're going to write to it. You take your fprintf file ID, so you're going to put a first row on that text file, and you're going to list the header for temperature. Then you're going to put just a big space like that. Then you do fprintf file ID. So it's always important to have these file IDs right here. And you're going to put the list of temperatures. Then from there, you are going to write a new line all by itself. Then you're going to have your speed in miles per hour, and that gets displayed on the screen or onto the file. And then you go through a for loop. That for loop will go row by row, and you're going to have temperature in the left-hand column, and then you're going to have a list of wind chill temperatures. That's wind chill, and this is non-wind chill temp. So this is like real temp, real temperature. And then from there you end each row with a new line, and then you close the file and you're done. Okay. You also need to have something called, it's a function called wind chill. If we go back for a second, we skipped over this really quickly. Your temperature for wind chill is equal to a function called wind chill that takes as inputs real temperature, okay, and k. So these are two different variables, okay? And so what you've got right here are your speeds, which are an index 10 through 60 miles per hour, and you've got your temperature right there, and it will do a calculation for wind chill. Now, this function, this is its own file. This is a MATLAB file, and it has to call windchill.m. Windchill.m contains the function windchill. So this is another file called windchill.m, and it's got a heading of function TWC is equal to wind chill, temperature, and velocity. And this is that equation that you saw earlier. Okay, and we'll assign TWC right here as the output, and you'll be able to calculate temperature. But it's really important to realize that there are two separate functions right here. One is the original function, the original file, okay, and this has a bunch of function calls in it. It's not an actual function, it's just a script, it's a MATLAB script, and it will call the actual function windchill.m, which have to be in the same folders. And that's it. So make sure to practice this. This sort of material will absolutely be on the final, and if you have any questions about it, feel free to bring them up in class or during my office hours.